this was my master's dissertation topic, spatial dynamics of UK e-petitioning. And I'll just go straight into it. And thank you all for coming and listening to me. So just a little background about e-petitioning. So public dissatisfaction in government politics and stuff has been on the rise for at least the last 4 or 5 years, especially in the under 30s. And one of the ways to try to combat this was a democratic innovation of e-petitioning. So there's plenty of different innovations that have come about, but e-petitioning is one of them, and it's been really effective in counteracting this public dissatisfaction and getting people involved in country politics. So in the UK's most prevalent petitioning platform was developed in 2015, and since then has received over 16,000 petitions and over 60 million signatures. So it's really, it's been really popular in the public to get across their feelings. And this is a new type of big data that is sparking a real shift in social science and opening the doors to new methods of analysis. In geographical clustering itself, what this paper was about, it's been used all over the place for many different reasons in social sciences. There's a paper written by Gale et al. In 2011 for output areas and clustering output areas based on socioeconomic factors. And it's good for gaining an insight into the population and marketing for companies as well, to get a sense of who is buying what in what areas. And like I said, it's been used in healthcare, education, and more recently in a paper by Clark et al. In 2017, public opinion. So that's kind of my motivation for writing this paper. Alongside, at the time, the kind of Brexit was very much in the news, and a lot of people were talking about it. It was something that I was very interested in, it, getting involved in politics and learning about different processes that were going on at the time. And it was something that I thought would be interesting to see how Brexit is thought about from using the petitions as a kind of a guide as to what the public opinion about Brexit is, alongside other topics. And also there was a gap for this sort of research in terms of looking at spatial analysis of e-petitioning, where particular people are petitioning for different things and hoping to try and get some sort of result. So that led me on to my research question, which was, how does public opinion characterised by UK e-petitions vary spatially across the United Kingdom? With 3 different aims: to determine the specific spatial trends in public opinion, evaluate the performance of appropriate clustering algorithms, and to explore variations in spatial distribution of constituency classifications against previous studies and against political outcomes like the general election and the Brexit result. So the methodological approach that I followed was straight away to extract the data, and that can be taken as an open source data from the UK petitions platform. Contrary to previous research, I wanted to try and create topics out of the petitions and the descriptions that were provided when a petition is made. So I used the unsupervised learning method, latent derelay allocation, to generate these topics. Then undertake some exploratory spatial data analysis to find some patterns between topics and within topics themselves. To cluster these topics into some specific classes to characterize the prevailing sentiment in that constituency, and to find if within this clustering to do some critical evaluation of potential methods I could use for this clustering. And finally, to visualize these results using thematic mapping and to discuss the variations as I alluded to earlier on. So just quickly to go through the extract process. Like I said, it's an open source platform to take the petitions from the government site. And a petition isn't a petition until it's received 5 co-signatories, and this complies with GDPR rules. as people are geolocated through their postcode that they provide, and then that's aggregated at constituency level. For this study, I only used petitions that have received over 10,000 signatures, and that cuts down some of the dross, I guess, because there were some that would only have about 10 signatures, and that to me wasn't really it's not representative of the entire country. The quality of the data, it had to be normalized by the population before starting the study, and some of the petitions being highly concentrated in nature were not included as well. For example, if a particular A&E centre in Huddersfield had a lot of petitions to keep it open, for example, they wanted to close it, a lot of petitions around the area would be signed by people local. So that doesn't, again, represent the entire country, as people in London are probably not going to be petitioning for an A&E centre in Huddersfield to remain open. And finally, just for additional data, I just needed a shapefile for constituencies in the UK, along with some information regarding the EU referendum and general election results. So for topic modelling, like I said, the unsupervised learning method latent zero-lay allocation was used. The process of which, and sorry, just to explain that, latent zero-lay allocation splits up the descriptions of the petitions into a bag of words, and then it looks for co-occurrences within this matrix and creates topics and generates topics from that. And to do this, there was a stage of pre-processing, so you have to remove things like stop words such as but and if and then, as they don't actually add anything to the bag of words. And then parameterization. This was trial and error, so I was using for looking for number of topics, the Dirichlet distribution and vocabulary distribution, and this was just trial and error, looking for the right parameters to use for the best fitting model. Used between 10 and 40 for the number of topics, and for the Dirichlet distribution 0.05 and 0.5. And then the goodness of fit was just determined by an R-squared value and the coherence measures. For clustering, there's two methods that I was set on using, mainly based on previous research. The first one being k-means clustering, which was used by Gale in his output areas study in 2011, and the other one, a Gaussian mixture model used by Clark in 2017 for his clustering of e-petitions. And just to quickly go through this, because I know that time is not of the essence. K-means clustering is just an expectation maximization approach, and it's mainly for hard clustering. So it's basically very binary in that a particular constituency belongs to one class or another, and there doesn't seem to be a grey area between. Whereas the Gaussian mixture model, again, it's kind of a soft version of that in terms of it classifies constituencies based on its probability of being in a class, which I thought probably would be quite appropriate when you're talking about public opinion, because nothing is ever binary in public opinion. You could have one person thinking one thing, and then on the next street a completely different thought process. So for looking at our results for latent Dirichlet allocation starting off, a K value of 30, so a number of topics of 30, excuse me, was found to be the best fitting for our purpose, and that gave an R-squared value of 0.18 thereabouts. But with a value of 1 being a perfect fit, this was probably considered a poorly fitting model, and coherence as well was pretty poor across all of the topics, with some being acceptable, others being not, and there was an average value of 0.138. But this might be explained because when a person adds a petition, it's generally quite colloquial in nature, and generally, well, rarely, most people didn't put more than 6 to 10 words in their description, and that can create the sparsity and co-occurrences in the matrix of the bag of words. But for this study, I decided that this was probably good enough for what I needed it for, and alongside some heavy subjective interpretation, which is said to be required in a lot of these LDA methods, I was able to produce this representative set of topics. Just to run you through that table to your right, some of the topics, because the best fitting model had 30 topics, where topics were quite similar to another, I just combined them together so that I didn't have 30 topic multivariate data set. And as you can see, health and social care had the most, was the most frequently petitioned about topic. So just quickly going over some of the exploratory spatial data analysis, each of the topics, as you can see in the table, have moderate to high levels of spatial autocorrelation, and you'd expect that from petitions. Generally, we've got quite a lot of low and high clusters for all of the topics. These two in particular were the highest and the lowest for defence on your right, and for education on the left. You can see even with the lowest level of autocorrelation at 0.458, you can still see those spatial relationships between constituencies for petitions of the same nature. And on to clustering. So for k-means, the model performance was assessed using its silhouette width to measure the measure of within cluster tightness. And through testing the k-values, so the number of classes between 3 and 8, we found that it was implementing a k-means algorithm with a k of 4 produced the best silhouette width, or average silhouette width, of 0.28. But as you can see from the graph, the silhouette width drops from an acceptable value of about 0.5 and gets progressively worse as you go through the constituencies. And that suggests that the fit is getting progressively worse, because what we would want to be looking for is larger silhouette widths to indicate a good fitting model. Also, we found some negative values in this, and they can be interpreted as the constituency that's being classified being more suited to an adjacent cluster. Then onto the Gaussian mixture model, and this algorithm estimated a model of 5 classes. So said, in other words, said that the constituencies with the information I've given can be split into 5 specific public opinion classes. And the performance of this model was determined by an uncertainty of assessment, and at a 95% quantile, this found that it was 90% successful. So 90% of the constituencies fell within a 95% confidence of it being in the correct class, which I thought was the best fit between the two clustering algorithms, like I said there. So here is the 5 classes against, in the class description. So we have class 1, so sectionalist, and each one of these has a popularity index where 1.5 equates to a 1.5 times more likely for someone to sign a petition relating to that topic in that constituency. So taking ruralist class, for example, they're going to be much more interested in things like livestock and wildlife, pets, maybe food-related petitioning. And as you can see, they have a 1.16 chance and a 1.28 chance more than the average of other classes to be petitioning for those topics. And that's how the classes were created, basically. And this is just a thematic map of those results. As you can see, there are 2 dominating classes: the sectionalist class, which is almost exclusively found in Scotland, Wales and Cornish constituencies; a suburbanite class generally seen bordering major cities like London, Manchester and Newcastle; and spelling mistake there, and the metropolitan and cosmopolitan classes, which are generally concentrated in cities such as Birmingham, Manchester and London. So for this research, the research question itself can be answered by discussing the results in a number of different contexts. The first is, where can specific clusters be found across the country? The next, how do clusters correlate with political allegiance? And again, how do these results correlate with previous studies using census data and previous petitioning data? So where can specific classes be found across the country? So metropolitan and cosmopolitan classes were generally centred in cities and urban areas and are typified by a more liberal attitude in terms of political allegiances. Suburbanites, often found in southern England and the Midlands, as you would expect, between the urban and rural boundaries, and these constituencies are generally more centre-right, anti-EU, and are largely uninterested in politics in general. And thirdly, sectionalist and ruralist classes, as we saw earlier around Scotland, Wales, and Cornish constituencies, as well as in the Midlands and in the North, are generally very vocal on issues relating to wildlife protection and keeping of livestock. However, where ruralist classes are generally in areas of the Cotswolds, sectionalist classes, like I said, are almost limited to Scottish constituencies in Wales. And how do these clusters correlate with political allegiance? So, as you can see, there's a cross-tabulation to the top right. You can see that the ruralist class are generally the most anti-EU and correlate most with the Leave vote, whereas you've got the metropolitan class, as you would expect, being more liberal and generally less traditional constituencies, generally voted more for Remain. And this supports the EU referendum voting patterns, which found that city dwellers are generally more passionate about remaining within the EU. And on the converse of that, these align well with official findings that found that sparsely populated rural constituencies are having up to 70% of the Leave vote. Now, how do these classes correlate with political allegiance? Again, here's a cross-tabulation. The Labour Party is highly supported in the more metropolitan and cosmopolitan classes, which would suggest that these voters are more central left. Whereas the Conservatives, Labour and Scottish National Party all hold a large proportion of the sectionalist class. And this was a bit strange considering that these parties are kind of in direct opposition. There's not a massive following for the Conservatives in Scotland or Wales. And that I put down to it being that these suggest that there's a broad range of issues on hand in these constituencies. People are not petitioning based on political allegiance as much as maybe elsewhere. So how do these results correlate with previous studies using census data and petitioning data? So the output area classification by Gale, that found 8 distinct classes in the UK based on the socio-economic census data that was available at the time. And this can act as a validation for our results. The vast majority of the results align very well with Gale's classes, and when you compare these two studies spatially, it's quite difficult to see the difference because of the difference in geographies. As Gale used output areas, I was only limited to constituencies. So we have to one of the assumptions and limitations of this study is that we have to assume a homogeneous public opinion across a constituency, which in real life is not going to be the case. We could have someone just down my road that's a completely different thought process to myself. Just cross-referencing our results with Clark's study in 2017 can assess actually our stability over time, as different petitions were available in 2017 than when this study was written. There is an obvious disparity in our results, being the generation of a 5th topic. And that would suggest that the more topics are being inputted into the petition database over time, as you would expect, and that's creating a new different type of public opinion that can be classed. We see a rise in the prominence of rural issues between the two studies, and we also are seeing that the UK is becoming more liberal over time. So the number of liberal constituencies when cross-referencing with political allegiance has increased by 8 over that time. So, as I touched on just now, the limitations of the study, the polarizing nature of some of the petitions does lead to a loss of information. And taking Brexit, for example, being one of the topics, there is only really a for and against argument, and there's no real middle ground for someone to petition for. And that means the moderate citizens are not going to be represented in these petitions. E-petitions are completely opinion-based, and it doesn't represent a whole population. There's going to be some people that don't know how to petition or that don't want to engage in the petitioning. And that also extends to the changing in opinion. So I know that my political thoughts now are different to 4 years ago, and I presume that for a lot of people that's going to be the same. And just the limitation of the methodological approach is that manually allocating these e-petitions into topics is an entirely subjective exercise, and there is also sometimes the challenge of one petition being able to be put in two different topics, and that's just going to come down to my personal opinion at the end of the day. Just some conclusions that I came to. The proposed methodological approach involving the application of latent zero-day allocation and a Gaussian mixture model to cluster these topics was capable of determining classes based on signing behaviour and with realistic spatial trends. There are 14 major petitioning topics, which, when clustered with the Gaussian mixture model, produces 5 distinct classes of public opinion in the UK. These results are consistent with relevant literature, but the findings are suggesting the country is becoming more segregated in its sentiment over time. Like I said, with the model creating the 5th class. And for further studies, filtering these e-petitions with a given time increment could show some interesting trends in space-time, as well as incorporating data from other petitioning sources, such as the Scottish National Petitions Platform. Thank you for listening. Has anyone got any questions?
Thank you very much, Elliot. That's a very interesting presentation, very well delivered. So, as usual, if you start typing your questions into the chat, if you could reserve your virtual applause till the end. Okay, so we have a question from Nick, who's obviously very interested in what you're trying to do. So he asks, is the code or data available for open source for further analysis?
Sorry, James, can I stop sharing? I'm getting a bit nauseous.
Yeah, maybe stop sharing. Either that or leave the presentation up.
Sorry, Nick, I will come to your... I don't actually know how we do this. There you go. As it stands, where can I see the question again?
So the question is the code or data available open source for further analysis?
Not as it stands, it isn't, but I'm more than happy to give my code, and also some of the code that was used was adapted from Stephen Clark, who I can see is in this call, and he provides the data as well in an R workspace.
Okay, thank you. That's a good answer. So the next question comes from Ming Hao, who's a current student working on similar data. So since petitions around Brexit account for 31% of signatures, to what extent do you think this might alter the results of the clustering classification, noting that Northern Ireland seems to be misclassified as metropolitan? And so do you want to start with that question?
I did think about the fact that the Northern Ireland was misclassified as metropolitan, and one of the things that was quite interesting and a limitation of the study is that I believe that both Scotland and Northern Ireland have their own petitioning platforms to use. So part of the reason why that misclassification, I believe, happened is because some of the more political problems, I guess, were being brought up on their own petitioning platform instead of the general national petitions platform.
Okay, so a question from Stephen Clark. So Stephen mentions that petitioners are allowed to add further persuasive text beyond a headline. So do you think the perhaps poor LDA fit might have been improved if you had incorporated this additional text?
Yes, I believe it probably would do. The more information we could have had, the better. But if you did read some of the study, you see some of the petitions were incredibly vague, and sometimes even included spelling mistakes and stuff like that, which can't have helped the generation of the topics.
Yeah, and now obviously the current big topic is going to be COVID-19, and I guess there's always some big issue dominating the data. So maybe another question is how, given that you tend to have some very big topics, how do you identify, how would you go about identifying emerging topics that might be interesting but might be kind of obscured by these big topics?
Yes, that was at the time as well the case with Brexit. One method that was, I believe, in another paper that I read, is just standardizing the data with, sorry, I can't remember exactly, but just standardizing the data so that it's not dominating the clustering process.